All right, let's get into it. Today we're going to tackle a really big idea in the world of software, infrastructure as code. And we'll talk about the tool that, for a lot of people, really defines that movement, Terraform. But to really get why it's such a big deal, we have to go back in time and understand the world before it existed. I just love this quote from Yevgeny Brickman's book. It totally sets the mood, right? It sounds like Star Wars for a reason. We're talking about a time when everything, servers, databases, you name it, was all managed by hand. This was an era ruled by these all-powerful figures we called sysadmins.
And believe me, this dark and fearful age was defined by some very real, very painful problems for anyone just trying to ship software. So let's talk about what that chaos actually felt like on a day-to-day basis.
Yeah, this slide pretty much sums up the nightmare. You see the snail there? That's for the deployments, which were just painfully slow and fragile because every single step was manual. And the snowflakes on the servers, that's for what we called snowflake servers. Each one was unique, slightly different, and totally impossible to replicate perfectly. All of this chaos led to that classic, age-old excuse from developers, well, it works on my machine. It was a constant battle.
So, pretty clearly, this whole manual way of doing things just wasn't going to work long-term. As companies tried to grow, this became a massive bottleneck. And it was out of all that frustration that a totally new way of thinking started to bubble up.
And that movement, of course, is DevOps. Now, the most important thing to get about DevOps is that it's not a job title. It's not one specific tool you buy. It's a philosophy. It's all about tearing down that wall between the people writing the code, the devs, and the people running it, the ops folks. The shared goal makes shipping software way, way more efficient, mostly through collaboration and, you guessed it, automation.
So you might be asking, okay, how do you automate an entire world of servers and networks and databases? Well, you do it with the one method that is the absolute core of the entire DevOps automation philosophy, infrastructure as code.
This right here is the big light bulb moment. What if you could manage a server using the exact same tools and practices you use for an application? I'm talking about things like version control, code reviews, automated testing, but for your entire data center. I mean, once you start thinking that way, it changes everything.
Now, infrastructure as code isn't just a single thing. It's a whole universe of tools. A better way to think about it is like a toolbox, where you have different tools that are specifically designed for different kinds of jobs. So let's open that toolbox and take a look at the main categories.
Okay, pretty much everyone starts here. You write a little script, maybe in Bash or Python, to automate a couple of manual steps. And for a one-off task, that's fine. But as your system gets more and more complex, these scripts just spiral into this tangled, unmaintainable mess. There has to be a better way.
And that brings us to the next level up, configuration management tools. Think Chef, Puppet, Ansible. Their job is to install and manage the software on servers that are already up and running. The key phrase there is existing system. They modify things that are already there. They also introduce really powerful ideas like idemotants, which is just a fancy way of saying you can run the same code over and over and it won't break anything. A huge leap forward from those messy ad hoc scripts.
Then you have a totally different way of thinking, server templating. With tools like Packer or Docker, instead of configuring a server that's already running, you create a perfect, self-contained image of it beforehand. This is where we get the idea of immutable infrastructure. It's a game changer. The rule is, once a server is deployed, you never, ever change it. If you need an update, you just build a new image and replace the old one.
And this slide just lays out the two main flavors of that templating approach perfectly. On the left, you've got virtual machines, or VMs, which basically pretend to be an entire computer, hardware and everything. Then on the right, you've got containers, like Docker, which are way more lightweight because they share the underlying operating system. Both give you that amazing consistency. They just have different trade-offs when it comes to how much overhead they have and how isolated they are.
Okay, so we've got tools to configure the software on a server, and we've got tools to create images of a server. But what about creating the actual server in the first place? Or the load balancers, the networks, the databases? Well, that brings us to our final category, and that brings us to Terraform.
And that's exactly what provisioning tools do. They don't care about the software running on the server. Their job is to create the server itself. Here's a great way to think about it. Configuration tools like Ansible manage the what, while provisioning tools like Terraform create the where. That distinction is absolutely crucial.
So how does Terraform actually pull this off? Well, you write a really simple declarative file that just describes the infrastructure you want to have. Terraform then reads that file, figures out what needs to be done, and makes all the right calls to your cloud provider, whether it's AWS, Azure, Google Cloud, whatever, to build it for you. It's basically the ultimate translator between what you want and what the cloud delivers.
And just look at how simple and readable this is. This is real Terraform code. It's not some complex programming language where you have to write out every single step. It's declarative. You just state what you want. In this case, hey, I want an AWS server, a T2.micro, using this specific machine image. That's it. Terraform handles all the messy details of how to make that happen. So, we've gone on this journey from the dark ages of clicking buttons in a web console to this clean, code-driven world. So let's circle back to the most important question. What's the payoff? Why should you care about any of this?
Well, the numbers kind of speak for themselves, don't they? According to the State of DevOps report, organizations that really embrace practices like infrastructure as code deploy 200 times more frequently. That's not a small improvement. That is a fundamental, transformational shift in how fast a company can move. It's a massive competitive advantage.
And when you look at the benefits, you realize they solve every single problem we started with. Instead of knowledge being trapped in one person's head, you get self-service for developers. Instead of slow and fragile, you get incredible speed and safety. That whole Snowflake server problem? Gone. The code becomes your documentation. You can version it, you can test it, you can reuse it just like any other piece of software. And honestly, it just makes everyone's life better by letting computers do all the boring, repetitive work.
So I'll just leave you with this one question to think about. This is the real paradigm shift that tools like Terraform represent. When you can literally define, version, and replicate your entire data center from just a few text files, what new things become possible then? Thanks so much for watching.